Alright, today we're going to look at Chapter 4, Topic 10. And Chapter 4, Topic 10 is an introduction to what are called imaginary numbers. They're called complex numbers or imaginary numbers. We've already kind of covered this first part where we're simplifying radicals. We didn't really look at the index because we're not going to be dealing with cubed roots or anything besides square roots. A couple properties to remember. Square root of a times the square root of b is equal to the square root of a times b. So an example of that might be something like the square root of 3 times the square root of 2 is equal to the square root of 6. You just multiply them together. This only works when these numbers are positive. Okay, so this 3 is positive, this 2 is positive. So this only works when those are positive. The quotient property says that if you're taking the square root of a fraction, you can split the square root among the numerator and the denominator. You can give it to each of them. Alright, we already looked at how to simplify radicals, but today we're going to look at how to simplify radicals that have a negative number underneath the radical. So when you take the square root of a negative number, we use the imaginary unit I to represent the square root of negative 1. Alright, I is equal to the square root of negative 1. So if we're trying to represent a negative square root, like for instance the square root of 4 would be 2, but the square root of negative 4 would be 2i. The I means square root of negative 1. So 2 is the square root of 4, but the square root of negative 1 is I. So essentially it becomes 2i. So when we're simplifying, for instance, number 1, the square root of negative 49, when we're simplifying this square root, well, the square root of positive 49 is 7. But to include the concept of the negative underneath the radical, we need to include the I, 7i. Because the square root of negative 49 is not a real number. It's imaginary, because you can't really take the square root of a negative number. So this is square root negative 49, which is 7i. Number 2, we want the square root of negative 20. Well, 20 simplifies to 5 times 4, and 4 simplifies to 2 times 2. So the square root of 20 is really the square root of 5 times 2 times 2. We have a pair of 2's that can come outside, so this becomes 2 square root 5. But since this is the square root of a negative number, we need to include the I. So this is going to be 2i square root 5. And the I will go after the whole number, but before the radical. So it goes after the whole number, before the radical. So this is 2i square root 5. It's just 2 square root 5 with the I to make up for the negative. Next we have 2 square root of negative 125. So 125 breaks up into 5 times 25. And 25 is 5 times 5. So 125 is 3 5s. Well, a pair of 5s can come out, so this is 5 square root 5. But it's a negative 125, so this is actually 5i square root 5. So negative 125 is 5i square root 5. Well, we've got this 2 on the outside, so that 2 and that 5 are going to get multiplied together because it's 2 times 5i square root 5, which is 2 times 5 is 10, 10i square root 5. It's kind of exactly what we did yesterday, except we're just including the letter I to show that it's a negative square root. Now this one's a little bit more complicated. Number 4, square root negative 2 times square root negative 6. Now, so if we multiply these together, we need to make them both positive first. So in order to make them both positive, this would be I square root of 2, and this would be I square root of 6. because you can only combine them when these two are positive. You can't do it when they're negative. So to make them positive, we need to bring out the I. Now this becomes I times I, which is I squared, and 2 times 6, which is square root 12. Now we don't write I squared because I squared is equal to negative 1. If you see here, I squared is equal to negative 1. So this would be negative 1 square root 12, or just negative square root 12. Number 5, we got 4 times 5, which is 20, and I times I, which is I squared. But remember, I squared is negative 1, so this is 20 times negative 1, which is negative 20. Now it turns out that if you keep multiplying I over and over again by itself, then you will get different results. So if you just have I and you just multiply it by 1, so I to the first, or you just have I to the first power, well, that simplifies to I. Now if you multiply I by itself, I times I, which is I squared, that becomes negative 1. If you multiply it by itself again, I times I, which is I cubed, that simplifies to negative I. And if you multiply it by itself 4 times, which is I to the 4th, that becomes 1. And then it starts over again. If you multiply it 5 times, 2, 3, 4, 5, I to the 5th, that simplifies to I. It starts over from the very beginning. So essentially, it cycles around in a loop of 4. It goes from I to negative 1 to negative I to 1, and then back to I, and then starts looping over again. So what that tells us, so this would also be I to the 5th, this would be I to the 6th, I to the 7th, I to the 8th, and then it would loop over again. I to the 9th, I to the 10th, I to the 11th, I to the 12th, and then it would loop over again. I to the 13th. Alright, so essentially we can figure out where it lies in this cycle. So like for instance, I to the 21st power. Well, I could loop through this thing a bunch of times until I figure out which one of these lines up with I to the 21st power. But there's an easier way to do it, and all I have to do is divide the exponent by 4, and then check out to see what the decimal point is. Alright, if I divide it by 4 and I get 0.25 as the decimal, then it's the first one in the cycle. If I divide by 4 and I get 0.5 as the decimal, it's the second one in the cycle. If I divide by 4 and I get 0.75 as the decimal, it's the third one. And if I divide by 4 and get 0 as the decimal, then it's the last one in the cycle. So if I divide 21 by 4, I to the 21st power, I'm going to get 5.25. Well, the decimal is 0.25, so that's the first one in the cycle, so this just reduces to I. I to the 11th power, so 11 divided by 4, that is 2.75. That's the third one in the cycle because it ends in 0.75, so that reduces to negative I. And 2022, so if I divide that by 4, 2022 divided by 4, I get 505.5, and 0.5 tells me that it's the second one in the cycle, which reduces to negative 1. Alright, so the homework posted on Canvas, be sure to check that out.